from algebra, or okay, we can start from question from linear algebra and then we can go for algebra. So the first problem, suppose if you consider the system of equation x plus y plus z equal to 3 and x minus y minus z equal to 4 and then x minus 5y plus k times z equal to 6. Okay, this is system of equation, and for what values of k, this has an infinitely number of solution. Okay, find k value for which this system has infinitely many solution. Infinitely many solution for what values of k. So the options are k equal to minus 5 and 0 and then 1 and then 3. So for what values of k, this system has infinitely many solution. So first you have to form a matrix equation. So the matrix equation is, the first row is 1 1 1, second row is 1 minus 1 minus 1, and then the third row is 1 minus 5 k times x y z equal to 3 4 6. Now what is the determinant of this one? So actually but we are going to look at the thing. So when the system have infinitely many solution, first when the solution exists, the rank of A should be the rank of the augmented matrix should be equal, and this should be less than 3, because 3 is the order of the matrix. Both rank and rank of AB should be less than 3 and should be equal anyway. So first you have to find the determinant of this matrix. So what is the determinant of this matrix? If the determinant is 0, then rank cannot be 3. Okay, from that we can conclude it. So just we can find the determinant 1 into minus k minus 5 minus 1 into k plus 1, correct, k plus 1, and then plus 1 into minus 5 plus 1. That should be 0, because if the determinant is non-zero, the rank should be 3, then you get a unique solution, but we need infinitely many solutions, therefore the determinant should be 0. So if you simplify this, we get minus k minus 5 minus k minus 1 minus 4 equal to 0. So this minus 2k should be minus 10, right, equal to 0. Therefore k should be what? Minus 5. Okay, so therefore k value is minus 5. Anyway, the rank not equal to 3, therefore less than 3. Therefore definitely if they are asking, they guarantee that solution exists, but they have to say infinitely many solution. That's why their determinant is 0. That is enough. Okay, now next question from algebra. Okay, so second question, the value of alpha for which this set form a group, for which the set G equal to alpha comma 1 comma 3 comma 9 comma 16 comma 27, this form a group, is a cyclic group, actually is a cyclic group under addition modulo 56, under multiplication modulo 56. So for what values, now what is the values of it? Anyway, this form a cyclic group. The what is the missing element, that alpha in that group? So the options are 5, 15, and then C should be 25, and then 35. It is given that it is a cyclic group, okay, and clearly 1 is the identity element, it is there. So all the, if you take we have to find the generator. If you find the generator, then everything should be a power of that one. Okay, so how we will find that one? Okay, so this is cyclic group, it is given. Okay, therefore actually what we have to find, we have to take the product of all the things. Okay, so it should be closed under multiplication. Anyway, don't bother about the cyclic or not. First of all, this become a group. So group means what? If you take any two elements, the product should be in the set with respect to modulo addition 56. Okay, so if you product with 1 and 3, 3 is there. Okay, so if you multiply 1 with any elements, that elements already is there, therefore is no problem. Suppose if you multiply 3 with this, 3 into 9 is 27, it is there. But what about 3 into 16? 3 into 16 is 48. Okay, am I correct or not?
Yes, sir.
But 48 is missing in this set, right? Am I writing correct? Yeah, but okay, modulo 56. Okay, so why they say it? Actually the options are not given, so I think maybe this is wrong, because if you multiply with any other elements, maybe we will check. So 3 into 48, but okay,
Sir, the operation is multiplication modulo, sir.
yeah, multiplication only. So I take, what is the 3 into 16 is 48. If you take modulo 56, if you take more than 56, you have to take modulo. Okay, actually maybe they will do some other things. Okay, I think they will take, what about 3 into 27? And this will be 171, right? If you take modulo 16, modulo 56.
Sir, 81, sir.
Yeah, sorry, 81. So if you take this, what you'll get? You'll get 35, yeah? No, 25. Right?
25, sir.
Yeah, 25 is not in the set, therefore maybe 25. But if you take, I think this is not 16, I think so. Maybe some printing mistake. I think this is not 16. If it is 16, then what about 3 into 16 is 48. Then 48 should be in the set, but 48 is not in the option. Okay, so I think maybe the printing mistake. This is not actually 16. Okay, maybe some other number. Okay, I think everything is a power of 3. There is 3 square, 3 cube. Maybe this is 3 power 4. Okay, maybe this is 81. But okay, if you take modulo 56, what you'll get? That is 48. But alpha is there. Maybe that is, I think, not 16. Oh, sorry. I am writing the wrong. Actually, that is 19.
Sir.
Yeah. So this is actually 19. Sorry, I wrote wrong. So actually 19. Now if you product with 3 into 19, you will get what is the 19 into 3? 7 to I think 5, 57. If you take modulo 56, you will get 1 is there. So okay, therefore if you multiply with 3 into 27, you will get 81. If you take modulo 56, you will get 25, but 25 is not missing, therefore alpha should be 25. Yeah, any doubt? Okay. So next problem. So the number of elements of order 8 in Z24. In Z24, integer modulo 24, okay. The number of elements of order 8. Number of elements of order 8 in the group Z24 is, so it's trivial. First 1, 2, 3 and then 4. So it's a cyclic group. Z24 is a cyclic group. In a cyclic group, the number of elements of order D is pi of D. Here pi of 8. So pi of 8 is nothing but number of elements which are related to 8. So what are the elements? GCD 1 with this 8, 1. And then if you take 3, the GCD of 3 comma 8 is 1. If you take 5, the GCD of 5 comma 8 is 1. And if you take 7, the GCD of 7 comma 8 is 1. So only 4 elements which are related to 8. Therefore pi of 8 is 4. Therefore there are 4 elements of order 8. Okay. Otherwise is a formula for pi of 8, and then you can write 8 can be written as 2 cube. Therefore 2 cube into 1 minus 1 by 2, we can cancel 1 2, therefore 2 square we get 2. Okay. Now next question. So now the fourth problem. Suppose the particular solution yp of x equal to x times cos of 2x is a, yp means particular solution, okay, is a particular solution of the given equation y double dash plus alpha times y equal to minus 4 times sin 2x. Then what is the value of alpha? Okay, what is alpha? That is a question. If this yp is a particular solution, then what is the value of alpha? So that should be solution. Okay, so the options are, so first option is minus 4 and then minus 2 and then 2 and then 4. Okay, now we know the formula for particular integral. So particular integral pi should be 1 by f of d into the function minus 4 sin 2x. Okay, sin 2x f of d, where f of d is d square plus alpha is the f of d. So therefore this is equal to 1 by d square plus alpha times minus 4 times sin 2x. You can take minus 4 outside. Now you got to substitute. What we have to substitute? You have to substitute d square equal to minus a square, that is 4. So therefore that if we get d square plus alpha square is 0, then you have to differentiate this sin by cos, right? Because the right hand side is given that the particular solution is x into cos 2x. If it is the denominator is non-zero, that is not a function, because the sign should be become cos. Therefore that should be 0. Okay, therefore this d square plus alpha should be 0. Okay, but we are substituting, sorry, not this one. So the denominator should be 0. Then only we can take we have to multiply x and then differentiate sign. Okay, now therefore if substitute d square equal to minus 4, therefore alpha should be 4. Then only we get 0. Then only we can multiply x and then you can differentiate this. What is the differentiation? 2 d. Derivative of d square is 2d into sin 2x. 1 by you can cancel 2 and then we get minus 2 x into 1 by d sin 2x is nothing but integration of sin 2x is nothing but minus cos 2x by 2 to cancel, we have minus minus plus, we have x into cos x. Okay, x into cos 2x. If substitute, therefore alpha should be 4. If alpha equal to 4, then only the denominator is 0, then we can multiply x and then differentiate the denominator, therefore we get here. Okay, so alpha should be 4. That is the answer. Okay, so already we know this one. Now the next question from linear algebra. So fifth question. So we have to find the basis, a basis of the vector space V. What is the vector space? Set of all x, y, z, w in R4 such that x plus y minus z equal to 0 and y plus z plus w should be 0 and 2x plus y minus 3z minus w equal to 0. So this is a subspace. Now in this vector space, what is the basis? Okay, so the first option, the bases are 1 comma 1 comma minus 1 comma 0 and 0 1 1 1. You have to check that elements are satisfy the given equations or not. Okay, that is the first thing you have to check. Otherwise you have to reduce the variable. So this is the first option. Second option is just 1 comma minus 1 comma 0 comma 1, just only one element. And then third option is again only one element, namely 1 comma 0 comma 1 comma minus 1. And then the fourth option is contains two elements, 1 comma minus 1 comma 0 comma 1 and 0 comma 1 comma 0 comma 1 comma minus 1. That is union of the B and C. Now which one is basis? Okay, so first you got to find the dimension of V. So how to find the dimension of V? You have to, there are four unknowns x, y, z, w. So using the given equation condition, you have to reduce the variable. So from the first equation you can replace z equal to x plus y. Okay, now we have x, now time being we have y, but z I am going to replace x plus y. Okay, now what about w? So look at the second equation, y plus z plus w equal to 0, therefore w equal to minus y minus z, therefore this is equal to minus y minus z equal to this one, therefore minus x minus y, therefore minus 2y minus x. So you can replace w by minus 2y minus x. Okay, now we can eliminate two unknowns z and w. Now we have two more variable x and y. Is possible to reduce x and y. Okay, so that is a case. So we can look at the third last equation. It is possible to write x in terms of y. So is it possible to write this thing? We can replace, I think it is not possible, maybe you will get. So okay, anyway, now if you take x outside, what you will get? 1 comma 0 comma 1 comma minus 1. If you take y outside, 0 comma 1 comma 1 comma minus 2. Okay, so these two elements definitely satisfy, but we have to check. Okay, anyway, so they are definitely, I think we get okay, otherwise we can check easily. So look at the first equation. You have to sum first two and then subtract the third coordinate, definitely that should be 0. Okay, but okay, look at this, sum these two 3 and then you can subtract third one, subtract minus minus plus, you will get 6, that is not equal to 6, not equal to 0. Therefore definitely this vector not satisfy the first equation. Or look at the second equation, sum of the last 3 should be 0. What is the sum of these last 3? Is non-zero. Therefore since this vector not satisfy the property, therefore definitely this is not a subset of V, therefore it cannot be basis. Okay, that is the first thing you have to observe. Okay, now either the B or C or D, there are two possible now. Now again we have to these three B, C, D always satisfy the first two equation. Okay, we can just add and then subtract the third one, you will get always 0. Okay, both B and C. Now look at the third one, we got to check the third condition. First you can check this and this. Okay, D is nothing but this union of this one. Okay, now look at this, x into 2 into 1 plus y but minus y, and then 3 times z value is 0 minus w is 1. So what is that? Actually this is equal to 2 minus 2, we will get 0. Therefore this vector satisfied all this equation. Now look at this vector. So again 2 times x value is 1 plus 0 value, y value is 0, z value is minus 3 times 1, that is 3, and then minus minus plus 1. Again this is 3 minus 3, we get 0. Therefore both are satisfy this equation, and these two vectors are linearly independent. We cannot get this vector by multiplying this vector by any scalar. Okay, therefore answer is D. Both the vectors satisfied, and one vector cannot be right as a scalar multiple of other. So therefore that is a correct thing. Maybe in the simplification maybe I will I did some mistake, that's why I get this one. Okay, so I don't know where I get where I missed that one. So y plus w plus z equal to 0, therefore w equal to minus y minus z, therefore everything is okay. And then otherwise you can use third, from the third equation w equal to 2x plus y minus 3z, but z is nothing but x plus y. So therefore we get minus 3x, we get x, and then minus m I get minus y. Yeah, w should be x minus y, not 2y minus 2x. Now we will get 1. Therefore from this we can conclude that these two are bases. Okay. Now next one, otherwise you got to check the vectors given in the basis, you can check it easily. Okay, so another, they will ask finding the matrix of a linear transformation for given basis. So this is a very important question, regularly they will ask in any examination. Suppose they give some linear transformation and then they will give some basis, you have to find the matrix corresponding to that linear transformation. Suppose T is a linear transformation defined from R3 to R3, is defined to be T of x comma y comma z equal to x plus y minus z, this is the first coordinate, and x plus y plus z is the second coordinate, and then third coordinate just y minus z. So with respect to this basis, what is the basis they given in the order 0 comma 1 comma 0, this is the first one, second one is 0 comma 0 comma 1, and then the third one is 1 comma 0 comma 0. Anyway this is standard basis, but it is given that in some order. Okay, so then the matrix of the linear transformation with respect to the order basis is this one. Now what is the basis? Options are, first option 1 1 1 1 1 1 minus 1 1 1 1 0 1 minus 1. So that is the first option. Second one is 1 1 0 1 1 1, then 1 0 minus 1. Then third option 1 1 1 1 minus 1 0 1 minus 1 1, and then the last one is 1 minus 1 1 1 1 1 1 1 minus 1 0. So first you got to find that the image of the basis, given basis element. Okay, so the order is very important. First they take this is the first basis element, therefore maybe we can actually, this is actually E2 and this is E3 in the standard basis notation, this is E1. Okay, So first you got to find what is t of t is a function, right? T of e2, that is x equal to 0, y equal to 1, z equal to 0. So therefore what you will get? You will get just 1 in the first two coordinates, 1 in the second coordinate, 1 in the third coordinate. Now this can be written as in terms of linear combination of e2, e3, e1, that is 1 times e1 plus 1 times e3 plus 1 times e1, that is the thing. Now what is t of e3? Next basis element is t of e3, that is z is 1, all others are 0. Therefore we get minus 1, 1, minus 1. Now we have to write in terms of e2, therefore 1 into e2, because the second coordinate is 1, e3 is minus, therefore minus 1 into e3, minus 1 into e3, the first coordinate is minus 1, therefore minus 1 into e1. Now the last base element is e1, so that is x is 1, all others are 0. So x is 1, therefore first one 1, second is 1, third one is 0. You have to write in terms of e2, so 1 into e2. What about e3? No e3, therefore 0 times e3 plus 1 times e1. Now we can write this as a column vector. So look at the first 1 1 e1, 1 1 1, everything is 1 1 1. And then if you look at the second equation coefficient, 1 minus 1 minus 1, and then third one is 1 0 1. Look at the third option C, you will get a matrix. Okay, so that is the answer. So this type of question they will ask, you have to find the matrix. So the order of the base is very important. Okay, don't take first e1, e2, e3. Okay, if they given first e2, first e3, and then first last e1, you have to do accordingly. Okay, don't change the order of the basis. If you change the order of the basis, the total matrix will change. Okay. Now another question from linear algebra. Okay, now the seventh question. So what the question says, suppose A is a 3 by 3 matrix, A be a 3 by 3 matrix, and suppose the eigenvalues are minus 1, 0, 1 are eigenvalues of this matrix A, and the corresponding eigenvectors. Okay, so the eigenvectors for minus 1 is, suppose you take the column vector, but I write in the row, I can take the column. So 1 comma minus 1 comma 0 transpose, this is the eigenvector corresponding to minus 1, and then eigenvector corresponding to 0 is 1 comma minus 2 transpose. Transpose means you have to write in the column wise, column vector, I write in the row way, I can put that. So the eigenvector corresponding to 1 is 1 1 1 transpose. So these are all eigenvectors corresponding to the eigenvalue given. So the eigenvector corresponding to minus 1 is this one, eigenvector corresponding to 0 is this one, eigenvector of this one is this one. Now question is, what is 6 times A? Then 6A, what is the matrix 6A? But we don't know what is matrix A, but we have to find what is 6A specifically. So the answer is, the options are minus 1, 5, 2. So there are so many ways we can quickly check this answer. Okay, so and this one is 2 2 2, this is the first option. Second one is 1 0 0 0, and then 0 minus 1 0 0 0 0, and then third one is 1 5 3 5 1 3 3 3 3. So the last option, minus 3 9 0 9 minus 3 0 0 0 6. So what is 6A? So you know the eigenvalues of A. So what is the eigenvalues of A? Minus 1, that is order is very important. So the eigenvalues of A are minus 1, 0, 1. What is the eigenvalues of 6A? You got to multiply 6. Therefore minus 6, 0, 6. Okay. Now sum of the eigenvalues of 6A is nothing but trace of the matrix. Now you find the trace of every matrix. So here if you sum all the things, you will get 0. Therefore you have to pick, first you have to eliminate those matrix whose trace are non-zero. We can eliminate that matrix because trace of 6A should be 0. Look at this matrix option C, that sum of the trace is 5. Therefore it's non-zero, therefore this is not an answer. Now all others are, maybe you can sum, you will get the trace is 0. Okay. Therefore all others are maybe possible, but we don't know which one is correct. Now again, what is the product of the determinant? So because product the eigenvalue is nothing but determinant. So again 0 is the one of the eigenvalue. Therefore determinant of 6A should be 0. Because 0 is the one of the eigenvalues of 6A, therefore determinant should be 0. Now can you find any so the other options you have to check. Look at the last option. You have to find the determinant of this one. You can expand via this 6, the last column. Okay, 6 times 3 into 3, 9 minus plus 9 minus 9 square. Okay. Anyway, this is non-zero number. Okay, therefore now here determinant is non-zero, therefore the option D is not correct because determinant should be 0. But if I look at this for option A, because option B the determinant is 0. Okay, because we have a 0 entry, we have 0 row or 0 column, therefore a matrix contains 0 row, either 0 row or 0 column, the determinant should be 0. Anyway, the determinant of B is 0. Now we have to find the determinant of A. So quickly we can find, if it is non-zero, we can omit that one. So that is minus 1 into 2 minus 2, minus 2 minus 4 minus 5 into 10 minus 4 and then plus 2 into 10 plus 2. So this would be minus 6 plus 6 and then 6 minus 30, yeah, and then this should be 12, 24. So we get 0. Okay, therefore we have to find another thing. Now how to find this one? Okay, so is using this eigenvector now. So you got to write all the eigenvector and the form a matrix. The first 1 minus 1 0 you got to write in the first column. So the first eigenvector you got to write in the column. So you given that 1 minus 1 0, and then the second vector is 1 1 minus 2, therefore you got to write in the second column, and then third one is you got to write 1 1 1. We call this matrix is P. Okay, and since the eigenvalues are distinct eigenvalues, therefore the matrix is diagonizable. Okay, so eigenvalues are distinct, then it is diagonizable. So diagonizable means what? Then A is diagonizable, then A is similar to a diagonal matrix. That means we can find an invertible matrix P such that AP some D P inverse, where D is the diagonal matrix and it contains all other thing. Okay, now we have to find P inverse. Actually, what is D? The eigenvalue, only the diagonal elements are eigenvalues of A. So therefore D is a diagonal matrix, the eigenvalues are only on the diagonal, all other entries are 0. So this is actually a diagonal matrix. So if you know the eigenvector, you can easily find that matrix P. P is nothing but just all the eigenvectors, corresponding eigenvectors. So definitely can easily check that the determinant of P is non-zero, therefore inverse of P exists. Okay, so once you find this one, you can easily find this matrix now. So we know what is P, we know what is D, we know what is P inverse. If you multiply, we get A. So once you get A, you can multiply 6 to the each term of A, we get 6A matrix. Okay, so maybe just to maybe take time, you have to find the P inverse. If you find the P inverse, already you know P multiply with this product P D P inverse, this is a 3 matrix, you will get A. So once you get A, just multiply with 6 to the each component, you will get a answer. Anyway, it takes time, that's why I leave to the exercise. So the option is first one. Okay, so first one is the answer. You have to find out. So idea is I give that. Okay, so I give the matrix P. How we get this matrix P using the eigenvectors. So since why I am writing this, because the eigenvalues of A are distinct, therefore should be diagonizable. So diagonizable means what? The A is similar to diagonal matrix. So similar means what? We can find a matrix P such that A can be expressed P D P inverse, where D is nothing but is a diagonal matrix, contains only the eigenvalues of A, and then P we can find using the eigenvectors of A. Anyway, just you find that one. Okay, now the next problem. I go to the next year. Okay, now question from linear algebra. Which question? 8th question. So 8th problem. Is simple problem. So what is that? Is give some subspace, and then you have to they asking what is the dimension. So that is simple one. So set of all x1, x2, etc. x5, x1, x2, x3, x4, x5, set of all x1, x2, etc. x5 such that 3 times x1 minus x2 plus x3 equal to 0. Okay, so we suppose we call this is V. What is the dimension of V over the vector space R? So the first option is 1, 2, 3 and then 4. So there are 5 unknowns here. Now we can take x2. Therefore x2 should be what? 3x1 plus x3. Now we can omit this x, we can replace this x2 by 3 times x1 plus x3. Therefore we have only 4 unknowns. Therefore answer is 4. Okay, this is a simple thing. Otherwise the number of coordinates minus number of equation. So here we have only one equation. Therefore 5 minus 1 we get 4. Okay, next question from algebra. Suppose G is a cyclic group of order 8. This is a cyclic group of order 8. The question is that the number of automorphism is, then its group automorphism has order. Its group automorphism, that is the number of automorphism they are asking, but they are asking a different way. Its group automorphism has order dash. So first option is 2 and then 4 and then 6 and then 8. And we know the theorem, if you take any cyclic group of order n, the number of generators is the number of automorphism. There are pi of n automorphism. So there are pi of here 8. So pi of 8 is 4. There are 4 automorphism. Therefore it has the group order. Its group automorphism has order 4. Any cyclic group of order n, it has pi of n automorphism. Okay, pi of n is a Euler phi function. Okay, next okay, maybe we can solve another problem. Integrating factor, finding the integrating factor. Tenth question, suppose if you look at cos y times sin 2x into dx plus cos square y minus cos square x into dy equal to 0. What is the integrating factor? Integrating factor of this one. So therefore this is not exact equation. If it is exact, then no need to find the integrating factor. If it is not exact, we have to find the integrating factor. So integrating factor is secant square y plus secant y into tan y, or the second one is tan square y plus secant y tan y. Then the third option is 1 by secant square y plus secant y tan y. The last option 1 by tan square y plus secant y into tan y. So how to solve this one? So first you have to write m and n, and then you have to find dou n by dou n. So m equal to cos y sin x 2x. Now we can find dou m by dou y. So you can fix x is a constant, therefore the derivative of cos is nothing but minus sin y. Sin 2x is fixed because x is constant here. This is dou m by dou y. Now what is n? N is cos square y minus cos square x. Okay. Now if you find dou n by dou x, this should be 0 minus cos square x derivative. First you have to take 2 cos x, and then derivative of cos x is minus sin x. Therefore minus plus sin x. Okay. Now find that anyway this is not a homogeneous. This is can write f1 of xy into y, all the format. So just to find the subtraction, dou n by dou x minus dou m by dou y, and then you have to multiply by 1 by n or 1 by m. One by m. So therefore 1 by, if the first one is dou n by dou x, I think 1 by n. So maybe we'll check. So what is m? M is cos y sin 2x. What is the subtraction? This 2 sin a cos a is nothing but sin 2x. Okay, there is a formula. Okay, sin 2a formula is 2 sin a cos a. So dou n by dou x is actually 2 times sin x cos x, therefore sin 2x minus dou m by dou, already we have minus, therefore plus sin y into sin 2x. We can take sin 2x outside, we can cancel, and then you get in the numerator we have 1 plus sin y by cos y. Now we get everything is a function of y alone, but we need a function of x alone or y alone in this formula.
Y alone.
Yeah, y alone. Therefore this is maybe we can call g of y. Now what is the integrating factor? Integrating factor is e power integral g of y dy. So e power integral 1 plus sin y by cos y into dy. Right? Now what is this? We can split into two integration of 1 by cos y, that is secant y dy, plus sin y by cos y is nothing but tan y dy. Now what is it? Answer. So what is the integration of secant y? Log of you get something. Okay, and then what is the, we can split into 2. So integration of e power integration secant y dy plus into, so okay, otherwise simply yeah, otherwise you can split into e power integral tan y dy. So this is simple, because if you tan y is nothing but log of thing. So e power what is integration of secant y dy, but what is the e power tan y is nothing but sin by cos. If you differentiate the denominator, you get a numerator, therefore we can just write a log of denominator, that is log of cos x is the integration of this one. So therefore log of cos y, that is the integration. So log and e cancel, we get cos y.
So log of secant x plus tan x.
Which one? Secant x.
Which one?
Integration of secant.
Log of
Secant x plus secant y plus tan y.
Okay. Now we can include this also, plus tan of log of cos y. No, what is the integration of tan y dy is nothing but, tan y is nothing but sin y by cos y. If you differentiate the denominator, you get numerator, we can write, but derivative of cos y is minus sin y, but minus is missing, therefore we can multiply minus. Now we can write minus log of cos y. Okay, therefore I got to put minus here, that's important. Now therefore log everything cancel, log a minus log b, log a by b. So what you will get? Secant y plus tan y by cos y. I am writing, I am right or not? Yeah, because log a by b. So what you will get? So we can split secant y by cos y. Cos 1 by cos y again is nothing but secant y plus tan y by cos y. So secant 1 by cos is secant into secant square y plus tan y can be written, otherwise you can take the sin 1 by cos is nothing but again secant y into tan y. So this is a secant square y, secant x, secant y, tan y. So that is the integrating factor. The first one, secant square y plus secant y into tan y is the integrating factor. Okay. Now next problem. Which question? 11th question. So again is a simple question. Suppose the set of all vectors for which we are collecting x, for which okay, this collection is a linearly independent. So what the collection? 1 comma x comma 0, this, and then 0 comma x square comma 1 and 0 comma 1 comma x. For what we are collecting x such that this is linearly independent. This collection. Okay. Now what is this collection? So what are the x such that these three vectors form a linearly independent? So the first option, this collection is nothing but collection of all x in R. So x is 0. Only 0 only satisfy this one. And set of all x in R, x is non-zero. If you take any non-zero vector, is always satisfied. And then C, set of all x in R, x should be not equal to 1. Other than 1, If you take any x equal to anything, is always linearly independent. And then the last one is x should be equal to 1. Sorry, x not equal to minus 1. Now what is that? So for what values of x, these three vectors form a linearly independent. So clearly, if substitute x equal to 0, we get a standard basis. If substitute x equal to 0, we get 1 comma 0 comma 0, and then 0 comma 1. Okay, sorry, 0 comma 0 comma 1, and then 0 comma 1 comma 0. So this is nothing but actually E1. This is E3. This is E2. Anyway, it's a standard basis. So therefore, x equal to 0. If you substitute x equal to 0, is always linearly independent. Therefore, we can omit the second option. Even if you take x equal to 0, that is linearly independent. Okay, suppose if substitute, look at the third one. If substitute x equal to 1, what you will get? You will get 1 comma 1 comma 0, and then 0 comma 1 comma 1, and then 0 comma 1 comma 1. If substitute x equal to 1, then you will get this one. Okay, so that means what? These two are same vector. Therefore, it's linearly dependent. Therefore, we can omit the last option, because if you take x equal to, they say except x equal to minus 1, all others are all for all values of x is linearly independent, they say. But if you take x equal to 1, we get linearly dependent. Therefore, we can omit the fourth option. Now, if substitute x equal to minus 1, what you will get? You will get 1 comma minus 1 comma 0, and then 0 comma 1 comma 1, and then 0 comma 1 comma minus 1. Okay. Now, is it linearly independent or not? That means if you linear one is is possible to write one is a linear combination of other. So in this option C is included 0 also. So if you take these three vectors are linearly independent. How to check these three vectors are linearly independent? For the case if you take x equal to minus 1, we will get this one, right? So definitely minus 1 is in the set. So how to check? Alpha times 1 minus 1 0 plus beta times 0 1 comma 1 and gamma times 0 comma 1 comma minus 1 equal to 0. We have to show that alpha beta should be gamma should be 0. So if you multiply alpha and then sum everything, the first coordinate is alpha, and then minus alpha plus beta plus gamma in the second coordinate. If you the last coordinate you get beta minus gamma should be 0 comma 0 comma 0. So from the last coordinate, if we compare, we get gamma equal to beta, and then first coordinate you get alpha equal to 0. From this, if substitute alpha equal to 0, we get beta plus gamma equal to 0. Therefore, beta should be equal to minus gamma. But already we know that here beta equal to gamma, but here we get beta equal to minus gamma. Therefore, both gamma and beta should be 0. Therefore, we get alpha equal to 0, beta equal to 0, gamma equal to 0. Therefore, if you substitute x equal to minus 1, we get linearly independent. But in the first option says only if x equal to 0 is linearly independent. It's not true, because if we take x equal to minus 1, we will get this one. So therefore, we can omit the first option. Therefore, this one is always true. Okay. Now another one is checking linear transformation. So given functions are linear or not. Okay. Suppose we have two functions defined f and g defined from R3 to R3. So defined by f of xy z equal to x comma modulus of y comma z, and g of x comma y z is defined to be x plus 1 comma y minus 1 comma z. So which one is linear? Both f and g is linear. Options are both f and g are linear. Neither f nor f is linear, and then one is linear, another one is not linear. So which one is linear, which one is not linear, or both? What is that? So linear transformation always take 0 goes to 0. It's very important basic thing. Okay, any linear transformation take 0 goes to 0, but g of 0 0 0, what is 0 comma 0 is goes to 1 comma minus 1 comma 0. This is not 0 comma 0 comma 0. Therefore definitely g is not linear. If it is linear, then it takes 0 goes to 0, but G not takes 0 to 0. But that is not the only condition, because look at f takes 0 goes to 0. But if it is linear, then what is the definition for linear? F of x1 x plus y equal to f of x plus f of y, f of alpha x equal to alpha times f of x. The scalar you can take outside. Okay, so if we take f of alpha times capital X, okay, capital X means this 3 tuple small x y z. Okay, if it is linear, then it satisfies this property. Now specifically we take alpha equal to some minus 2, okay, and specifically take x equal to some value 1, 2, some 3 something. So what is f of alpha times x? So nothing but f of, you have to multiply alpha to each coordinate, we get minus 2, minus 4, minus 6. By the definition of f, this should be minus 2 and then modulus of minus 1 we get 4, and then we can take the z. But what is alpha times f of x? So alpha is minus 2 times what is f of x? Again you have to take 1, modulus of 2 is 2, 3 z. Therefore if you multiply we get minus 2, minus 4, minus 6. These two are not equal, because here the second coordinate is 4, but here the second coordinate is minus 4. Therefore these two are not equal. Therefore this is not satisfied. Therefore f also not linear, because it is not satisfied the second property. Therefore neither f nor G is linear or linear. Okay, so this is also a very important thing. Okay, maybe the remaining problems we will discuss in the next class. Almost we solve problems. Okay, I can stop now.